This is recording 4 for Project Echo. Welcome back. My name is Rylan Mercer, and I'm the owner of Mercer Mechanics here in Neo City 11. I'm continuing work towards the main division of the original Mecha contest, or the OMC. Echo, or the Elite Covert Hybrid Operative, is engineered to stand out in a crowd full of strong contenders. Last time, we made 3 unique backpack modules that allow Echo to fulfill its hybrid roles. Today, we will try to finish up, well, everything. I've tried to make this complex process as easy to follow as possible, but there's a lot happening, so try to keep up. I'll start with the arms, then legs, torso, and backpacks. Let me know if the organization of this recording can be improved. When I began work on the arms, it was clear that I needed to add more thrusters to sharpen Echo's agility and turning. Given the success of the thruster system on each foot, I implemented a comparable configuration on the outside of the forearms. When I have a chance to revisit a task, I always aim for better results. This time, I reinforced the arm and thruster for a stronger mount. The same rocket nozzle, starter system, and air intake valves from the rollerblades were attached but had to be oriented differently. I of course did everything twice, and mirrored, but throughout this recording we will revisit a lot of parts and do the same tasks many times. As with most mechanical systems, managing thermal load is critical. I decided to use a reliable compact venting setup, but needed to mill out a recess to secure it effectively. An active cooling intake diverter was installed on each limb, which is designed to channel airflow through the unit and provide additional cooling to nearby components and systems. Various microsystems are attached across the entirety of the mech, including gyroscopic sensors, which will help Echo's navigational system to apply the correct forces in the right directions. One type of necessary microsystem includes auxiliary power cells that will generate and store extra energy during the mech's runtime. Basically, a car battery that will be used per limb thruster. These power cells are not necessary, but incredibly useful in initial startup of each thruster, and in the case of the arms, it will provide extra power for the servos within the hands and fingers. Because of how many components are being added, I may not cover every system shown. If you have any questions or comments, feel free to share them and I'll clarify any info that I can. Across many surfaces, I've attached high-tensile aero strips that will help manipulate the airflow dynamics to control vortices and reduce drag. Small manual levers and access ports are finally being implemented to help with maintenance and repairs. The legs receive a similar treatment to the arms, with additional armor to protect the critical ankle pistons. I'm mindful to test motion as often as possible to avoid future issues. The complexity of the ankle assembly warrants its own microcontroller subsystem, complete with integrated venting. Low-profile, slipstream air blades help protect the rear of the ankle pistons, while also stabilizing motion by minimizing wake turbulence. I like clean wiring just as much as the next person, but I opted for shrouded conduits across most of the mech in order to reduce air drag and protect sensitive cables. There aren't many places left on the foot to mount an auxiliary power cell, so specialized fitting was used to mount one above the thruster. The hardware for the knees and elbows can be better protected, so a heavy metal ring was welded around the fixed side and filled with a talcum acrylic composite material. Rotational interface optimizers were attached to each knee and elbow to dynamically adapt the coefficient of friction in each joint. Larger vents were necessary on the active cooling intake diverters for the legs. I managed to fit an additional power cell and venting within the thigh assembly, where more power is needed locally to manage the weight of the mech. Modular access hubs are attached in various locations to provide connectivity for system diagnostics. Cleanout ports are fixed to the end of each limb assembly to assist in flushing out and repressurizing hydraulic systems. Similarly, the higher speed but lighter load pneumatic ankle pistons need a connector for managing the high pressure air. Aerostrips of various sizes are utilized wherever they will fit within the design, matching up the legs with the arms. The twin pistons in the thighs need a more stable pivot to push against, so I made some. Interlocking knee armor was attached to both the bottom and top of the joint to help protect the internals while it is sharply bent. At this point, I merely continue to implement the same sensors and functionality previously used on the arms before closing up the modular access hubs. Various components are reinforced with an extra metal plate for added durability. With all of the microsystems finalized for the limbs, it is easier for me to see what is still missing from the upper body and how much clearance I have for those components. The heavier arms warrant additional support in the shoulders, while additional spacing in the torso needs more protective armor. The pelvis internals are highly complex, with many moving parts that need to be protected at all times, so I put in a bit more effort getting effective armor paneling. I wasn't satisfied with the air filter and vent combo systems I had available, so I went out of my way to create a self-contained module that can mount directly to the pelvis. Thankfully, I could still use a pre-existing vent for the large area on the back. The cockpit for Echo still needed input sensors for general navigation and piloting. Custom optics were assembled from scratch to ensure optimal integration. The cockpit hatch itself received an ionized air filtration system and reinforced hinges. A secondary optic system was mounted to provide binocular vision for enhanced targeting and depth of field. An auxiliary coolant tank was slotted into the front armor to keep the pilot and surrounding systems at optimal operating temperatures. Metal trim was welded around each of the shoulder and hip joints to reinforce the connections. Aluminum foam backer rod was formed specifically for the connection between the shoulders and the cockpit and helps to mitigate vibrational wear between the two assemblies. After sealing gaps, armor and microsystems were attached as necessary. One set of pre-made armor panels was too thick for use on the shoulders, so I used it as a template to make some thinner replicas. With the mech itself complete, I moved on to each of the backpack modules to make sure they were built to the same standard. The recon pack received a truckload of sensors and electrical connectors. The autocannons were mostly complete and needed minor additions. The nuclear jetpack, however, still needed a lot of work to become fully functional. Stabilizers, modular access hubs, microcontrollers for various electrical systems all needed to be implemented along with the electrical and fueling systems themselves. And by fueling systems, I of course mean a singularity catalytic fluid ecosystem, since the actual fuel being used is the lithium cell within the pack. With a few injection starter ports, and sensor arrays, and coolant lines, and armor, the jetpack was finally almost complete. This period of workdays has been just that, quite a lot of work, but I am definitely proud of how far the Echo design has evolved. There's still the problem of loose ankles to address that I have admittedly been procrastinating. Thank you to everyone who recommended possible solutions though, and I'll see what I can pull off in stabilizing them. Is this mech going to be an OMC winner? Only the judges will know that. But stick around for the next recording and let me know what you think after we get some paint on this bad boy. That's about it for the building phase. Maybe I'll add some more bolts, but for now, I'm white. This has been Rye at Mercer Mechanics. Stay inspired. Thank you to those at the Royal Archive for supporting small creators like myself. End recording 4.